Hi, in this series of videos, I'll solve the free response questions from the 2023 AP Stats exam. This is my solution to question 3. Bath fizzies are mineral tablets that dissolve and create bubbles when added to bath water. In order to increase sales, the Fizzy Bath Company has produced a new line of bath fizzies that have a cash price in every bath fizzy. Let the random variable x represent the dollar value of the cash price in a bath fizzy. The probability distribution of x is shown in the table. All right, there's a table. Here are all the different values of x, and here are all the different probability values, except that there's a number here that's not filled in. And sure enough, based on the probability distribution of x, answer the following. Subpart I, calculate the proportion of bath fizzies that contain $1. So sure enough, they want the probability over there. Okay, probability of x equals $1 is 1 minus the sum of the probability that x is not equal to $1, and that is equal to 1 minus all the rest of the probabilities. 0.2 plus 0.05 plus another 0.05 plus 0.01 plus another 0.01. And that is equal to 1 minus 0.32, which is 0.68. Part II, calculate the proportion of bath fizzies that contain at least $10. At least $10 means all of these people. And that means 10, 20, 50, 100. And it is equal to 0.12. Part B, based on the probability distribution of x, calculate the probability that a randomly selected bath fizzy contains $100, given that it contains at least $10. Well, the probability of containing $100 is 0.01, so 0.01 contains $100. Out of 0.12, at least 10. Therefore, the probability of having $100, given that we're getting at least 10, is 0.01 divided by 0.12, which is the same as 1 divided by 12, which is 0.0833 repeating. So we're rounded to 0.083. Now, if you want to use the conditional probability formula, you can. Probability of B given A is probability of A and B divided by probability of A. So this part here goes in the denominator, and the both of them go in the numerator. Well, to be 100 and to be at least 10 is just 100, because once you are 100, you are at least 10. So this is actually the same as probability of 100 divided by probability of at least 10. And therefore, we have 0.01 divided by 0.12. That would be the second solution using the formula. I think if you're using this formula, the risk is that you're calculating that as multiplying the two of them together, and you're going to end up getting the wrong answer. Part C, based on the probability distribution of x, calculate and interpret the expected value distribution of the cash price in the bath fizzies. The expected value of x is equal to the sum of x times probability of x just plug in all the numbers. So all the numbers are here with the 0.68 here going into the box of $1. 1 times 0.68, that's $1, plus 5 times 0.2, 10 times 0.05, 20 times 0.05, 50 times 0.01, 100 times 0.01 is 4.68. And what does this mean? This means, interpret. It's an expected value, so it's something you expect. And these things involving probability are always things in the long run, according to the law of large numbers. So we can say that in the long run, over many bath fizzies, the amount in each fizzy is expected to average 4.68. That's the interpretation of an expected value. Now, part D, the fizzy bath company would like to sell the bath fizzies in France, where the currency is euros. Suppose the conversion rate for dollars to euros is $1 equals 0.89 euros. Using your expected values for part C, calculate the expected value in euros of the distribution of the cash prize in the bath fizzies. Show your work. If I let Y be the value in euros, then Y is 0.89 times X. So the expected value of Y is equal to the expected value of 0.89X. And then a property of expected value is that you can factor these coefficients out. And so I can multiply it like that, and I get 4.1652 euros. This is a full answer. It includes this part that justifies how you can just take the 4.68 and you multiply by 0.89. Now, I don't know what the rubric will do to you if all you have is this. I don't know. Are you allowed to just assume that a dollar can just convert to euros directly? Or do you have to have this part that mathematically justifies? I don't know. That's question 3. For my solution to other questions, check the description section. If you have any questions or comments, or especially if you think I'm wrong on something, please write in the comments. Subscribe for more contents. Check out my statistics playlist for more videos, and thanks for watching. Bye.